In this video, we're going to be covering units, and there's a few different things we're going to be talking about, both in general, what are units and what role do they play, but we'll also be looking a little bit at how units are converted. There are some major learning objectives that this ties to. One is the idea of communication, that in physics, we're always talking about different types of quantities, and the units that that quantity has tells you something very fundamental about it. So we really can't communicate anything about a quantity if you don't have units with it. The second learning outcome that this relates to is the idea of problem solving, that units can be used to actually verify that your approach has made sense. Understanding the units of a quantity it gives us a clue about how different quantities relate to one another, and it can help you understand the mathematical ideas that you need to move from input data to some sort of result. So units are really fundamental to many things that you do in this course. So the first thing is to briefly just define what units we're going to focus on. So SI is the Système International, or pronounced probably much more French, of units, and this is also going to look like the metric system. So for those of us who have only worked in the United States, in our education or otherwise, we're probably not used to these. However, within scientific classes, you usually do. So kilograms are going to be the units for mass. So for instance, we usually think about weighing an object, but this is within a physics context, also thinking about the mass of an object. So don't think about this as actually being equivalent to pounds, but right now this is really going to be for mass. Now the second fundamental unit that we will be working with are seconds. Now luckily this is one that we all hopefully are used to. And obviously there are other time units like minutes and hours and days, and you can use those in physics, but the fundamental unit where we will relate things to is the second. Finally, the length isn't going to be in inches or feet, but it will be in meters. And derivative of meters is going to be centimeters, millimeters, kilometers, things like that. But the fundamental SI unit is going to be the meter. Now, one thing to be a little bit careful of here is that M can also be the symbol for mass. And so when you're doing work, remember that when you're writing M next to a number like 2, that should mean 2 meters and not 2 times mass, or you need to at least keep track of which one it is. We're going to be talking about many different units in this class, but almost all of them that you're going to meet are going to be able to be expressed in terms of kilograms, seconds, and meters. One exception is called the coulomb, which is the fundamental unit of charge, but we won't see that until Physics 203. So in Physics 202, everything we meet can be expressed in terms of kilograms, seconds, or meters, though frequently we're just going to learn a different word for it, like joules. So you know that there are quantities that we talk about, either in real life or in science, that aren't measured in meters, kilograms, or seconds, and these are going to be compound units. So for instance, I want to think about an equation for average velocity, where this is equal to the displacement vector divided by the time elapsed. So this is going to be one way of just defining velocity. Now in this case, these are going to have units. Now, usually we're going to actually have units of meters for our displacement and seconds for time, which means that the units that we will get for this velocity vector is meters per second. Now, as you might know, when you're sitting in a car, the speedometer tells you something about your speed, and speed is also going to be measured in the same units as velocity. However, we don't see meters per second, so some of the other units that we're going to have for speed, you might be familiar with mph, which is equal just to miles per, where that's division, hour. And that's really helpful if you want to think about time in hours and distance in miles, but that's not actually going to be how we talk about speed in this class typically. So another, as this speedometer here shows, is kilometers per hour. And in general, again, we want to focus on meters per second in this class, and you'll need to get a little bit of a feeling for what 1 meter per second actually feels like, since you're used to thinking about 40 or 70 miles per hour. When we want to talk about the units of speed, we always just say meters per second, or again possibly miles per hour. We don't have a special word that we use. Many quantities are going to have special units that have their own name. So for instance, force, as we will talk about very soon, has the units of newtons, which we abbreviate as capital N. Now this has a special name, but it actually can be expressed in terms of these fundamental units. 1 newton is equal to 1 kilogram times a meter divided by seconds squared. So we could always write that and say that the units for force are kilograms meters over seconds squared, and that's true, but it gets a little unwieldy. So instead we say that it's newtons, and we can write it that way. So as we encounter units in this class, such as joules for energy, we can express it back in terms of kilograms, meters, and seconds squared.